Alright, so today we're going to continue our lessons on inequalities. The last few days we learned about how to read them, how to graph them, how to write them. Today we're actually going to look at how to solve algebraic inequalities, ones that are going to require that we use the addition property of inequality and the subtraction property of inequality. So let's get right into what those things mean. So kind of like with equations, I can solve algebraic inequalities using the addition property of inequalities and the subtraction property of inequalities. And what those say is when you add or subtract the same number from each side of an inequality, the inequality remains true. So let's look at the number examples before we go back to the symbols. Okay, so I know that 2 is less than 4. That's true always. So I know if I add 3 to each side, I'm going to get 5 on this side and 7 on this side. What we're looking at is I started with the number on the left being smaller than the number on the right. So that means that the number on the left should end up being smaller than the number on the right, meaning I can retain my less than sign. The same is true for subtraction. We know that 6 is greater than 3. If I subtract 4 from each side, I'm going to get that 2 is greater than -1. So again, I started with what was on the left being greater than what's on the right. I ended with what was on the left being greater than what's on the right. So again, in symbols, it's just explained that if I have A is bigger than B and I add the same amount to each side, whatever is on the left is still going to be greater than whatever is on the right. And the same is true for if whatever is on the left is smaller than whatever is on the right. If I add or subtract the same amount, the symbol stays the same. Okay, so let's try using this. So the first thing we need to think about is how inequalities are different from equations. So the big main difference that we need to know is that equations have one answer, while inequalities have infinitely many answers. Okay, what does that mean? Well, we know that x plus 2 equals 12. That's an equation. We already solved those and took a quiz on those earlier. So we know that's an equation, not equations. And we know that since we have a less than symbol here, x plus 2 is less than 12. That's an inequality. So let's solve the equation based on what we know how to do. I'm going to subtract 2 from each side. That's going to give me x is equal to 10. So when I solve an equation, I have one answer, only one answer. That's possible. I can only graph one dot. There's only one number that makes this equation true. Now on the inequality side, I'm going to use the subtraction property of inequality. I'm going to subtract 2 from each side. I'm going to get x is less than 10. So here I actually get an infinite number of solutions. I get that x could be anything that is smaller than 10. It actually cannot be 10, but it could be 9, 8, 7, 6, anything that is less than 10. Okay? So let's actually try to put this in practice. At this point, if you feel confident enough to pause the video and try to solve this without me, go for it. So we have a plus 10 is greater than or equal to -3. I'm going to isolate my variable by subtracting 10 from each side. That's going to give me a is greater than or equal to, well, I know that -3 minus 10 can be solved the same way as -3 plus -10, which is -13. So a is greater than or equal to -13. So I have a solution of multiple solutions. So I go to graph this. Okay, so let me graph and scale my graph by 2's. So I'm actually not going to put 0 there. I'm actually going to put 0 up here and go 2, 4, 6, 8, and then -2, -4, -6, -8, -10, -12, -14. I know -13 is going to be between -12 and -14, and I know since it's greater than or equal to, I'm going to have a closed circle because it can actually be equal to -13, and I'm going to shade to the right. So when I go to solve this, I get a lot of solutions. Well, what do those solutions mean? Well, I know if I plug in -13 here, -13 plus 10 is actually -3. -3 is greater than or equal to -3. Let's try another solution. I'm saying that 2 could possibly be a solution. So 2 plus 10, is that greater than or equal to -3? Let's find out. 2 plus 10 is 12, which is true that it is greater than or equal to -3. So everything from here on over is a possible solution to this inequality. Okay? Let's try another one. C plus 15 is greater than 9. So to isolate my variable here, I'm going to subtract 15 from each side. I get C is greater than negative 6. So when I go to graph my solution, it's going to be an open circle, and I'm going to shade everything to the right. And again, when I look at my inequality, if I want to check my answer to make sure it's true, let's pick a number that's greater than negative 6. Let's pick 2. 2 plus 15, is that greater than 9? Yep, 17 is greater than 9, so that checks out as true. So all of these answers here are possible solutions to this inequality. All right? I think we're ready to try one on our own, so I would say pause the video again. So let's start solving this. To isolate n, I'm going to add 7 to each side. I'm going to get n is less than or equal to 22. Now in this case, I still need to scale my graph. So you want to typically put 0 somewhere closer to the middle, but if you can't, you can always put it to one side or the other if the numbers end up being really large. Since my answer is n is less than or equal to 22, I'm actually going to scale my graph by 11s, because I know that that will allow me to have an exact point at 22. So I'm going to put a closed circle since it's less than or equal to. And this tells me to shade to the left since it's less than or equal to, values that are less than or equal to. Okay? So one more before we get to our problem of the day. Again, pause the video at this point and try on your own. I have d minus 12 is less than or equal to negative 18. I'm going to add 12 to each side. That's going to give me d is less than or equal to negative 6. I go to graph. I'm going to put a closed circle at negative 6 and shade to the left. Okay? Alright, so that wraps up our lesson. Here's our problem of the day. Go ahead and try these 4 before tomorrow and be ready to volunteer to put them up on the board. Alright, have a great night.